Welcome to Train Signal. I'm Chris Bryant, CCIE number 12933, and this is the fault tolerance and disaster recovery video. While you take a look at the list of topics that we're going to be discussing in this video, I want to mention that as far as I'm concerned, this is the most important video in this course by far. And not just because it's important for you to know for the exam. I mean, obviously we're here to prepare you for the Network Plus exam, and I know that you'll pass that. I'm not even worried about you passing it. What you've got to be concerned about with the material in this video is in real-world networks and the sometimes cavalier fashion in which fault tolerance plans are put into action or not put into action, whether a disaster recovery program actually exists. And it can really be as simple as just making sure that someone is running data backups. And that's a task that tends to be put off onto someone else. You know, everybody thinks it's someone else's job to check the backups from last night, and then maybe that person does it in midday instead of doing it first thing in the morning, and a backup didn't run, and oh, I don't want to run a backup while the users are on the network, so we'll just run one tonight. You have to be really careful and really vigilant with that because there's very little exciting about running data backups. Okay, I'll be the first to admit that. If you think it's exciting, fantastic, but most people do not. But you want excitement? Try explaining why you don't have a data backup the day after an important drive fails. Now, that's exciting, and we don't like that kind of excitement in this business. So we're going to talk a bit about that and inject some real-world situations into the data backup discussion we're going to have. We're going to talk about the levels of RAID, and if you're not familiar with that, you certainly will be very soon. But before that, we're going to discuss briefly surge protectors, UPSs, and line conditioners because they're very different devices, and there's a strong misconception about one of these that I want to clear up for you immediately. Because I want to tell you, when it comes to this stuff, you know, we like to think positive. And I'm an optimist. I'm a very optimistic man. But I know, having worked around networks long enough, and I'm going to tell you, I don't care if you've been doing this for a day, week, month, year, decade. No matter how proactive you are, no matter how vigilant you are, sooner or later, something in your network is going to break. And it could be something that's not your fault. I mean, hard drives go bad. The power goes out. It can be that simple. Hard drive and a server goes bad, data's lost somehow. Any of these things can happen to any network on any given day. And a network's fault tolerance is a measure of its ability to continue to operate and recover from such occurrences. And I want to tell you one more time, that day is going to come. It's not being a pessimist, it's simply being realistic. We've got so much going on in the network, something's going to break. Sooner or later, we have to be ready for that. The first aspect of fault tolerance we're going to discuss here is very basic and it's very important, electricity. You know, I've talked a couple times in the videos here about data being all ones and zeros. Well, if we don't have electricity, we don't have any ones and we don't have any zeros. And a question to ask yourself, if the power went out in your server room right now, or where your backup drives run, what would happen? And if the answer to that question is, I'm not sure, or it begins with, I think, that's not good. So let's talk about this and some other power issues as we examine the different options for managing a networked power supply. And the first one is a surge protector. Now, an electrical surge, what is that to begin with? It's a sudden increase in voltage. Now, the voltage change itself can be very slight, but if you've worked with computer hardware at all, you know that it doesn't take much electricity to fry a network card or to harm the other physical components of the computer. So all we have to be careful about static electricity when we have the computer open or a server open. We've got to ground ourselves because even some static electricity can damage the device beyond repair. And since surges are common, it's also a cumulative effect because the cumulative effect of continually little surges here and there, that can harm a PC and it can also harm a network device. And there are surge protectors and there are surge protectors. Now, everybody's familiar with the surge protectors that people use in their homes for their PC. It's going to look something something like this strip here that I've got a couple of servers plugged into. And the baby surge protectors that you pick up, you know, the ones you see at the grocery store for $8.99, something like that, the surge that those devices are designed to protect from are normal changes in the household voltage. I am not saying that those devices are useless. What I am saying is that a lot of PC owners, and I know you don't think those, but a lot of people think that these surge protectors, the small ones where you plug 6 devices in a row, are going to protect against lightning strikes. And that is nowhere near the case. We're talking tens of thousands of volts in that case, and a little baby surge protector that you got at the drugstore is not going to help with that. Now, surge protectors that are capable of protecting a home PC for more severe surges, you can get those at most office stores. You can certainly buy them online, but sometimes buying some of these devices online can be expensive just for the postage. So they're available in office stores. And really, overall, surge protectors are really the least effective method available for protecting our devices from problems with power, because they're good at what they do. Now, we overrate their ability sometimes, but as far as protecting from normal surges and voltage, yeah, they do that. But the problem is they offer zero protection against power outages. And we certainly don't want our servers going up and down and up and down every single time, you know, there's a thunderstorm outside. And I've been around networks where there were severe winds and the winds could blow the line, all of a sudden the lights would start blinking. Well, the lights can blink, but we can't have our servers blinking. So while surge protectors, like I said in the picture here, they do just that. They do protect against surges, but they don't supply any kind of power when the regular power source is unavailable. The surge protectors you find in most production networks today are actually a combination of a surge protector and an uninterruptible power supply, much more commonly referred to as a UPS. And with the UPS, we're actually going to have the UPS connected to the power source, and the network devices are plugged into the UPS. And should the power source become unavailable, the UPS will immediately kick over to battery power and continue to supply the devices connected to it with power. And if you have a server plugged into a UPS and the UPS cuts over to the battery, the server should receive an uninterrupted supply of power, which is why we call it an uninterruptible power supply. And you've got a couple of factors that determine how long those devices are going to get power, because occasionally network admins act like, well, I got a UPS, so, you know, when it kicks over, I don't have to worry about it. Well, yeah, you still have to worry about it if the power doesn't come back on immediately, because the length of time the UPS will keep these devices powered up is dependent on two major factors. The first is the number of devices you've got connected to it, because you've got a battery in the UPS, and it's only got so much power, and if 6 devices are draining power from it, obviously it's going to be a lot faster than if you just have 2 devices connected to it. The other key is the capacity of the battery itself. And if you go to your local office store and you look at the UPS selection there, and you'll see several major vendors, I won't mention any particular names, but they sell in almost every major office store in America. And you'll have some devices called uninterruptible power supplies. You'll have some called battery backups. You'll have some called a combination of the two. You need to watch that, because you can buy some of these devices and they kind of look like on the box, oh, well, they've got 8 plugs, I can connect 8 devices to this, and, you know, they'll still all get power. But not every plug on there is an uninterruptible power supply outlet. Only half of them will be, and the other halves will just be surge protectors. Nothing wrong with that, but just a word of warning, you want to read the boxes kind of carefully when you're looking at those at office stores. And also take the claims of, you know, 6 devices stay up for 3 hours, anything like that, a little bit of a grain of salt. I would not wait until the last second to shut my servers down cleanly if my power's been off for a while, because, and of course your production networks, they're going to contain UPSs that aren't bought off the shelf, and of course they cost tens or even hundreds of thousands of dollars, but you'll be glad you didn't go cheap when the power goes off and your network stays up. Now, I mentioned a because there a second ago, and what I want to refer to here, whether you're at home or whether you're at work, the key to working with UPSs is to make sure that your computers, your servers, your laptops, I don't care what it is, do not let them go down hard. And by that, I mean don't let them just suddenly be switched off due to a lack of power, especially a server. You do not want that. And with UPSs, they're going to have LEDs on the front. And generally, a green light indicates that it's online, which means the power source, the normal power source, is online. And then when it kicks over to battery power, there's a light under the green one that's amber, and it'll say battery or something like that. And you'll see the amber light go on. But of course, you're probably not spending your day staring at the UPSs in your server room. At least I hope that's not what you're doing all day. And what you need is a little audio signal. Well, the UPS is going to be glad to give you one. And depending on what model you buy, it may drive you insane before the power comes back on, because they're pretty insistent little signals, but they're just letting you know, hey, you know, there's a problem with the power here. Now, most UPSs will beep when they're in action, and as the battery gets to the critical stage where it's really starting to wind down, the beeping gets more insistent. And that is letting you know you need to come over here and shut the servers down, because you want to do that before the power runs out, because a lot of operating systems, and I'm not going to mention any names here, but when they go down just from a lack of power, they don't always come back real well. And then you've got another issue to fight. So make it easy on yourself. If you're in a server room and you hear that beeping and all of a sudden, you know, the beeps are like a second apart or 2 seconds apart, there's a reason for that. Go over there and see what's going on with it. Now, theoretically, if you want to achieve the highest level of protection from electrical problems, the way to go is with a line conditioner. And this is, again, the highest level of protection from electrical problems. What actually happens, line conditioners actively monitor a device's supplied voltage and will switch from one transformer to another as needed to keep the voltage within an acceptable range. I do mention, and here's the understatement for this video, they are not cheap. There's a reason that not everybody has a line conditioner in their network somewhere. Now, obviously, when I'm talking about transformers, I'm talking about a higher level of knowledge needed with electricity to even get these things started up. It's certainly not something you go to, you know, the office store and just plug into the wall and go. So if you're even faintly interested in these, you know, do your due diligence, do your research online, and look into that. But I just want to give you the theory of that again, the line conditioner is going to give us the highest level of protection from electrical problems. So now that we've covered a couple of devices that can help us out as far as power goes, you know, surge protectors, not much fault tolerance there. You know, there's a little bit of protection from voltage, but if the power goes out, the power goes out. The surge protector doesn't care. The battery backup, or the UPS unit, is going to give us some juice when we need it, and it's going to start beeping when it's almost out of juice. And then finally, a line conditioner gives us an even higher level of protection from power issues. So now that we've talked about power problems, the next most common failure, actually probably more common than power outages, is what happens when good hard drives go bad. And again, I don't mean to sound like a pessimist, but hard drives fail. Repeat after me, my friends. Hard drives fail. And there are some network admins out there, there are some networks out there that really do not take the proper precautions when it comes to disaster preparedness, and that's particularly true of hard drives going bad. And today, I'm just going to put it right on the table with you. Today, there is no excuse for not having the proper backups and for not having the proper disk failure plans in place. And again, you don't want to be the guy sitting there making excuses. You know, well, you know, we always meant to put RAID 3 in, but we never did it. You don't want to be that person. You do not want to be in that chair. Because as you're going to see in a moment, a disk failure plan is really quite simple to put into place. And it's getting easier all the time. And we've got quite a few different levels of RAID to choose from. But first, I want to talk about what it actually stands for. It originally stood for a redundant array of inexpensive disks, but it's also known as redundant array of independent disks. I say, who cares? It's RAID and that's it. But there are some people, you know, we like to argue about things in this field. I don't know if you noticed that yet or not. We like to argue about which one it really is. I personally don't care. Network Plus exam really doesn't care. It's not going to try to trick you as to what it stands for. I personally prefer the latter because it's a little more descriptive of what RAID is all about. Because what we're doing here is we're taking multiple physical hard drives and combining them into one logical drive. And that helps to lessen the impact of a physical hard drive failure. And it can also actually help performance. And that all depends on what level RAID we decide to implement. And we're going to look at some common ones here and some not so common levels of the redundant array of inexpensive and or independent disks. Before we get into the different levels of RAID, though, let's talk just a moment about hardware and software RAID, because we've got two different ways to implement RAID, which we're looking at here, and several different levels of RAID as well, which are going to follow. And there are two really good reasons to learn about all of these. First off, different networks are going to use different levels of RAID. You walk in one day and see RAID 6, you walk to another network, you see RAID 5, you walk to another network, you see RAID 0. So it's a good idea to know what's going on with all of these. Secondly, certification exams really like asking about this stuff, or any list, but especially RAID for Network Plus. I would be very well versed with it. So let's talk about hardware and software RAID here for a moment. Again, the name is the recipe. Hardware RAID uses a separate disk controller for RAID, and software RAID uses software to configure RAID. Just a little bit of history here. Hardware RAID used to be considered superior to software RAID because it did actually work faster. But with today's rapid processors, and they're getting faster all the time, software RAID can actually be faster now than hardware RAID. But, and there's always a catch, if software RAID is using too much of your CPU, obviously other operations are going to suffer. That's the balancing act we always have to walk with the CPU. So that's just a little background there. And again, depending on what OS you're using, you may be able to implement RAID without even buying a software program, because the latest versions of, I know, Novell NetWare, of Windows Server, they've got built-in RAID programs. A lot of laptops come with built-in RAID. A lot of PCs you buy right off the shelf. One I bought recently for my office just had RAID all ready to go with multiple disks, which was nice. So once we decide how we're going to implement RAID, we've got to decide what level we're going to use, and that's going to depend on what kind of fault tolerance we need. That's going to depend on the number of drives involved as well, so pay particular attention to that as we start our discussion with RAID 0. RAID 0 is disk striping and no parity. And the bad news is it's got no fault tolerance either. This is the lowest level of RAID, RAID 0. And for good reason. It offers absolutely no fault tolerance at all. And I know I said that twice in 60 seconds, but it's that important to know. What does happen with disk striping increases performance by writing data across multiple drives and using multiple disk controllers rather than writing all the data to one physical drive. So here, just for an example, and by the way, when we combine drives in RAID, we call that an array. We are placing a drive into an array, a RAID array. And here we've got a 96K file coming in, and basically what happens with RAID, if we're using 3 drives, RAID 0, is that roughly 32K, 1/3 of each of that file, is going to be written to each drive. This is disk striping. And again, that's a RAID 0 array. And the disks do not have to be identical in size to be placed into a RAID 0 array, but the smallest disk does limit how much space on the larger drives can be placed into an array. And let's consider this example where we've got 3 disks to be placed into a RAID 0 array. We have 3 drives here. We have a 100 meg drive, a 500 meg drive, and a 750 meg drive. And it would be easy to look at that and say, oh, you know, we can make one that's 1.35 meg. It's actually gig, excuse me. But we can't do that because since disk 1 is only a 100 meg drive, only 100 meg on each of the other drives can be placed into the array, which means we end up with a RAID 0 disk array of 300 meg. So we can't use the full capacity of all three drives, and maybe we don't want to. We probably would. And again, the smaller drive is the one that's holding up the work, so to speak. It's dictating that we can only put 100 meg of the other two drives into the array as well. This is also a good illustration of why we call it disk striping, because you're basically painting a stripe down the hard drives, and the stripe is going to be the same width no matter which drive you're on, and it can only be as large as the capacity of the smallest drive in the array. With RAID 0 here at the bottom of the whiteboard, I've mentioned the good points and the bad points. And the good news is we do have increased productivity. It's actually more productive to write files across multiple disks than just to write to one. And it does allow us to use all the physical drives and all the disk controllers. But the bad is pretty bad. There's no fault tolerance. And once again, I mention that because if one drive goes bad, the entire array is down. And stepping back, you can see why that's true, because let's say we needed to retrieve that file and the middle drive is down. Well, getting the first 32K and the last 32K of a file is not going to help you. You got to have all three parts. And if one of the drives goes down, you can't get all three parts. So with RAID 0, if one drive goes bad, the entire array is down. Disk duplexing and disk mirroring are two terms that are occasionally misused or used interchangeably, and they're not the same thing. So before we go any further, I just want to make sure we're all on the same wavelength there. Disk duplexing does involve multiple drives, but it also involves multiple disk controllers. So if the physical controller goes bad, the other drive is still accessible. That's not the case with disk mirroring. Disk mirroring has one disk controller for multiple hard drives. So controllers don't go bad often, but they do. And if they do and we're disk mirroring, we've got a problem. But with duplexing, we do not. RAID 3, disk striping with parity. Now, RAID 3 and RAID 0 have one similarity. They both use disk striping, but RAID 3 is much different in every other way. RAID 3 uses the error correction code, the ECC, to find errors through the use of parity bits. And parity bits can be either odd or even. If this is the first time you've heard of parity bits, it may be a little confusing at first. Don't worry about it. I would be surprised if you saw this particular information on Network Plus, but you need to be prepared. And you also need to know what this is. Well, with even parity bits, the parity bit is set to 1 if the number of ones in the data bits is odd, and 0 if that number is even. If odd parity bits are in usage, then the parity bit is set to 1 if the number of ones is even, and 0 if odd. And like I said, if that makes your head spin a little bit the first time you hear about it, do not worry about it. It makes everybody's head spin a little bit the first time you hear about it. Because this parity bit, here's how we detect the errors with it. The parity bit is set when the data is written to a drive. And when the data is accessed, when it's read from the drive, the number of ones in the data bits is counted again and compared to the parity bit setting. And if the parity bit still matches the number of ones in the string, then the data is fine. But if not, there's been some kind of error involved. And just a quick example here of how it would look. And again, it would depend on whether you've chosen to use even parity or odd parity. But if you have 7 bits of data, 7 bits that all read as all zeros, with even parity, the parity bit for that would be set to 0, so it would just look like 8 zeros. With odd parity, the parity bit would be set to 1, so it would be 7 zeros and then followed by a 1. So again, that number, that data is read, and this information is checked. The amount of ones is counted, and if it's still what it was when it was written to disk, either odd or even, then everything's fine. It's an error detection scheme. It doesn't actually correct the error, but it will find it. Now, you might have detected a small flaw in that error checking scheme, because if 2 out of the 7 data bit values actually change and are corrupted, then we'd still have an even number or an odd number. So that's really catastrophic, though, for data. You're not going to see that very often, where 2 of the data gets so corrupted that 2 of the bits change value. Again, an error of that magnitude is rare, and RAID 3 really does a pretty good job with error checking. So again, just want to review that with you with the parity bits. RAID 3 uses the ECC to find errors through the use of parity bits. You can choose odd or even, and that's really up to you. And again, it counts the number of ones. That's what is going on. And if you're using even parity bits, the parity bit is set to 1 if the number of ones in the data bits is odd, and 0 if even. If you're using odd parity bits, the parity bit is set to 1 if the number of ones is even, and 0 if odd. So hang in there. That's as bad as it gets. But really, once you practice with it a little and just really go through that theory a few times, you're going to be fine with it. Now, a more serious drawback to using RAID 3 and just leaving the parity bits behind is the requirement to dedicate a drive to serve as the parity drive. This drive is not going to participate in disk striping at all. So what we end up with is something like this, where a 64K file comes in, and it is going to be striped. You can see it's going to act just like RAID 0 did, and write half of it to the 2 drives. It's going to spread it out fairly evenly. But the 3rd drive is reserved for parity. So we're not writing any data to it. That drive does not participate in disk striping. So what this means is that we need a minimum of 3 hard drives to use RAID 3. And actually, for all 3 disk striping methods we're going to talk about here, RAID 0, RAID 3, and RAID 5, as I say here on the whiteboard, you've got to have 3 drives to run RAID 0, RAID 3, or RAID 5, at least 3. With RAID 1, you don't need 3. You can get away with 2. The RAID level that delivers the highest level of fault tolerance of all the RAID levels that we've talked about so far is RAID 5. And this is really the RAID level you'll see most often in today's networks. It's similar to RAID 3. It does have parity, but notice that this is disk striping with distributed parity. So here we've got 3 drives, 3 controllers, and a 33K file coming in. And that data is going to be written to all 3 disks because the workload of parity is distributed among all the drives. We have a distributed parity scheme. We do not have one drive that's sitting there having to handle all the parity work. So by distributing the parity information as well as the data, the fault tolerance of RAID 5 is the highest of any level that we've discussed at this point. And of course, when I'm saying to this point, I must have a point, right? We must have something higher coming up. And that is RAID 6 and RAID 10. These are not common yet. I've seen a little bit of RAID 6. I have not seen RAID 10 in person yet, but I know it's out there. It's pretty expensive to put into action, as we're going to talk about here. Now, RAID 6 is really a lot like RAID 5, and it's basically an extension of RAID 5. But where RAID 5 distributes the parity scheme, RAID 6 has a second independent parity scheme. There are actually 2 parity schemes. We call this, of course, dual parity. Now, both of RAID 6's parity schemes are written across all the drives, the same way that we just saw RAID 5 writes parity across all the drives. Dual parity actually allows RAID 6 to recover from a failure of 2 simultaneous disk failures, where RAID 5 allows recovery from only a single drive failure. So if you're in a situation where you've got to be able to guarantee your boss or your network admin, whoever, yes, we can recover from a failure of 2 simultaneous disks, then you better be using RAID 6. That is the allure of it. Now with RAID 10, You know, RAID 10 is one of these things that just sounds great when you look at the benefits. And here again, I've got it listed as good and bad. It has the same fault tolerance as RAID 1. It's implemented as a striped array of RAID 1 segments. It has excellent input-output rates, and it can also recover from multiple simultaneous drive failures. So we've got RAID 6 and RAID 10 that can both recover from multiple simultaneous drive failures. The bad of RAID 10, it's really expensive, it's not scalable, and it does have high overhead. You know, other than that, it's really good. I'm sure if you tell your boss, hey, it's really expensive and it doesn't scale, and it's going to take up a lot of our network resources, then he or she is going to say, hey, go for that, man. I like the sound of that. Another key here, and I will put it on the whiteboard as well, that both RAID 6 and 10 require at least 4 drives. And that is a minimum. So that's another reason you might not see it all that often. So there, you know, with the disk striping of 0, 3, and 5, we have to have at least 3 disks. But with RAID 6 and 10, we can recover from multiple simultaneous drive failures, but we have to have at least 4 drives to implement either one of them. That concludes our discussion of RAID. And before we go into talking about specific data backup plans and disaster recovery plans, I want to share with you the key to a successful disaster recovery plan. Create one. If I was going to change that a little bit, I'd say create and implement one. Because fault tolerance that we've talked about so far, it's not fault invulnerability. You know, no network is invulnerable to problems. And no matter how hard we work to avoid, you know, single points of failure, sooner or later, something happens to a part of our network. And part of being a world-class network manager is not just being reactive. And here's that dreaded buzzword. It is about being proactive. You've got to have a disaster recovery plan in place, and in place before the disaster hits. It doesn't do you much good to have your server room flooded out or shorted out, or something else happens to it, and then you go, hey, wait a minute, you know, we got to have a plan here. You don't want to be in that guy's shoes. What you want to do is create a plan in advance and be ready to implement it. Because, you know, as silly as it sounds for me to even say this from one professional to another, it does you no good to implement a data backup strategy after the data's lost. You know, or as one of our grandparents would have said, the horse has already left. It's a little late to lock the gate. And I bring this up because having a sound backup system in place is a vital part of network administration. Let me ask you this right now. If an email server in your network failed right now, would you have a backup? Would you be able to restore as much data as possible? You know, you're either going to be in one of two situations when that happens. You're either going to be restoring the data, or you're going to be explaining to somebody why you can't restore the data. And no one wants to hear the explanation, because the explanation is not putting the data back on there. And again, you know, it's rare to find a network that has no backup system in place, but when it comes to tape backups, you know, having the disk drives and everything there and assembling all that, that's not the hard part. It's making sure that people keep the tapes current. You know, I have personally visited networks where they had a tape drive right there in the server room, and the tapes were right next to it, and everybody thought somebody else was handling that. And the tapes were not labeled. They had no dates. They had no nothing, frankly. And that's where you and I do not want to be. Part of developing a data backup strategy is also deciding how often to run them and what kind of backups to run. Because it's not always feasible to back up all the data on every single server every single night. I mean, it's just not going to work that way. You probably don't have the time, because you don't want to be running data backups while your users are on the network changing files. Before we go into a discussion of the 3 backup types, let's talk about the archive bit for just a moment. Now, theoretically, the archive bit of a file is going to be set to off when the file is backed up. And when a file is first created or altered, the bit is set to on, indicating that it has not been backed up. Now, different applications are going to allow you to manipulate the archive bit in different ways. That's real world. I want to tell you that. But right now, we're really concerned strictly with the theory of that archive bit and the backup types, because the key here is to not only know the backup types, but to know why you'd have to choose one over the other, and to know what tapes you're going to need if you're running tape backups and you've got to do a restore. You know, if you're running incrementals, what tapes do you need? If you're running differentials, what tapes do you need? Well, before we get to those two, let's talk about the full backup, and that's really just about all we need to talk about, because it is indeed a full backup. It's going to back up all files. These are occasionally referred to as normal backups in some books and documentation I've seen. It's an odd name because there's nothing normal in our business. But if you see something referred to as a normal backup, it is a full backup they're talking about. The incremental and differential are the two you need to keep straight. An incremental backup is going to back up all files created or changed since the last backup of any kind. Now, all the files with the archive bit set to on will be backed up, and the archive bit is cleared after the file is backed up. Now, that's the normal behavior you would think about. Well, yeah, anything that has changed since the last backup is going to be backed up, and then the archive bit will be cleared. Well, differential backups don't work quite that way. What differential backups do is they back up all files created or changed since the last full backup. The archive bit is not cleared in a differential backup. So you have the possibility, or the probability actually, of having the same file backed up on multiple differential backups. And you may think, well, you know, why are we going to do that? Well, here's one reason why. Here's a typical backup schedule. Now, granted, most networks, and hopefully yours, back up files every night. But as we're going to discuss in a few minutes in more depth, there are reasons that you just can't run a full backup every night. Excuse me. And the first one is time, because you can run them on the weekend, and that's probably not going to be an issue, because we don't want to run backups when we've got users on the network, if at all possible, because they're changing files that we may be trying to back up. They can't access them, they get mad, and your phone starts ringing. It also slows the network down, period, when you're running backups. It slows access to files on that server. So let's say that we're running a scheme where we're running full backups on Sunday and some other type on Tuesday and Thursday. And the drive goes bad on Saturday morning, and you get the call, and somebody else gets the call, hey, you got to get your button here and do a restore. Now, this is where confusion tends to sink in, and I've seen it time and time again where network rooms don't have their tapes labeled. Nobody knows what kind of backups they're running. Nobody knows where the tapes are. That's really bad. But you don't want to be the person who's confused about, you know, hey, what tapes do we need to do this restore? Well, it depends on what type of backups you're running during the week. If you're running differential backups, you only need two backups. You need the last full backup and the last differential backup to run a full restore. If you have been running incremental backups during the week, you would need the last full backup and every incremental backup run since then, every single one. So that's one major difference between the two, is that with differential, you only need the last differential backup. But with incremental, not only do you need the last full backup, you got to have every incremental backup tape you've run since then. There's no right or wrong answer when it comes to deciding what kind of backup types you use and when you put them into place, as long as you're running them. You know, that's really the key. But the three questions you need to ask yourself when choosing what kind of backups to run. First off, how much data needs to be backed up? Are we looking at, 50 meg? Are we looking at 6 gig? How much is it? What's the capacity of the backup media? If you're using tapes that only hold 100 meg, you're going to have a hard time backing up some of today's servers. So what is the capacity of the backup media that you're using? And then finally, and really the most important question, how much time do you have to run this backup? Because again, you don't want to be running a lot of backups when your users are on the network. I've been there, trying to get a desperate backup when somebody hasn't run it, and somebody just demands, well, you got to run this backup today. Well, it hammers the server. It makes it very difficult for users to pull files off of it. It makes it impossible for users to access some files. It makes it impossible to run the backup. It's just a real nightmare. You don't want to run backups when you've got a lot of users on the network. So these are the three questions that I ask myself when I'm looking at what kind of backup types to run. And you can go online and find different arguments about, incremental versus differential. And like anything else, it's something that we really enjoy arguing about. And they both have pros and cons, but what you want to be concerned about right now is knowing the details of each and knowing what tapes you would need to perform a full backup if you were running differentials during the week or running incrementals during the week. Because believe me, I've seen arguments in network rooms over it. You don't want to be there. Now, the method and storage of the backups, again, we were just talking about the media that we're using, and I say tape backups a lot because that's mostly what I've used, but I have backed up to CD and I have backed up to external drives, so let's talk about those. And the method that you choose depends on how much data you have to back up, as I mentioned, and no surprise here, how much money you have to spend. Because tape backups are really the cheapest of these three. The external drive may be cheaper, but I really prefer a tape backup system from a dedicated tape drive. Again, we could use optical media. You could burn the CD, write the CD, I should say. That does take a while. It takes longer than tape backup. So again, when you're looking at these options, just do the diligence, dig into it, and say, okay, we want to write to CD. How long is that going to take us? If it's going to take a long time to run a full backup, how often do we want to run it? Generally, a full backup once a week is enough. I know plenty of networks, though, that back up every server totally every night. Nothing wrong with that either, as long as you have the resources to do it. A couple of different network terms, storage terms I want to introduce you to here. DAS, NAS, and SAN. So since we've got a lot of acronyms there, we really want to differentiate it. And again, if you just think about what these actually stand for, it's pretty straightforward what they're going to do. Direct Attached Storage, DAS, describes any device that is attached to the device itself. Technically, an internal hard drive is a direct attached storage device. I don't like that definition. There are a lot of other people who don't, but technically a hard drive is a direct attached storage. What I think about is an external storage device attached directly to the server, just a little tape backup device there that you could attach to the box itself. Network attached storage, NAS, is a much more scalable solution because let's face it, direct attached storage is not scalable. The more boxes you buy, the more little storage devices you got to buy, and it's just not practical to keep up with. NAS involves putting a storage device or devices directly onto the network. It's a central point of data access and storage for the network clients themselves. Now, SAN, storage area networking. And by the way, NAS does give you some fault tolerance too, because hosts could possibly access data from the storage device if the server they usually attach to goes down. That's not going to happen automatically, but you can make it happen. Now, with SAN, this is a huge up-and-coming part of networking. And a SAN is simply, it's a portion of the network that contains nothing but storage devices. I've heard it referred to as a storage subnet. I think that's a good term for it. It's actually a network on your network, and the mini network, if you will, just has storage devices. And all servers on a company LAN or WAN have access to these storage devices. Now, SANs today are found mostly on enterprise wide area networks, and an enterprise WAN is a really big wide area network. So a SAN is not something you're seeing in every little store, any server room these days, but it's definitely an up-and-coming area of the field. Cisco has actually added several certifications that relate strictly to storage area networking. So if you're looking for an area to specialize in down the road, and I think that's a good idea, we all want to be utility players and know a little of everything, but it's always good to have a specialty. you could do worse than SAN. Definitely has a future. Has a future. Hot, warm, and cold sites. Now, before we go too far down the whiteboard here, again, part of disaster recovery is having someplace to go while you're recovering from the disaster. You know, if your server room was destroyed tonight by either something man-made or nature, where would you go tomorrow? And that's something you have to think about before something like that happens. Now, some companies and government agencies are going to have everything a company needs to keep operating off-site. They're going to have another location, preferably far from the primary site, because you should assume that if there's a disaster, a natural disaster, then it's not just going to hit one building, it's going to hit multiple buildings. So you want to keep these sites away physically from your primary location. And the sites that have everything you need to just walk in and start working are called hot sites. They contain everything from office furniture to telephone equipment, and they're maintained by commercial companies for their customers. You hire someone to keep that up for you. It's not something your company probably does on its own, because obviously it's a very expensive proposition. Now, these sites, again, they cover everything from the office space all the way through the computer equipment. And the servers at the hot site are actually going to be mirrors of your active servers at the primary location. So you should be able to walk in and without much difficulty get your business back up and running. Now, on the other end of the spectrum, we have cold sites. Cold sites will have the physical devices necessary to get up and running again, but they're not configured and they're not mirrored. They could be sitting there in boxes. And obviously that's cheaper than maintaining a hot site, but your organization has to ask itself, do we want to wait while someone gets all our backup media from the off-site location where we better be saving it all the time anyway, and not be able to get back to work until those servers are mirrored and everything's restored to them? And the answer is probably not. If you're going to the trouble of having an off-site location in case of disaster, you probably don't want a cold site. That's time that a lot of companies and government offices and public utilities just can't spare. And I've actually helped build 2 hot sites. And you've been in there and you're in this room and they have all these nameplates for, government officials and that kind of thing. And actually, it's a little surreal, because you know that this room's only going to be used if something really bad happens. But mostly it's governments and larger companies that keep hot sites running. There is a middle ground, thankfully, and that's the appropriately named warm site. Now, warm sites are going to have all the physical equipment needed, along with some of the servers configured and maintained. Most likely the more crucial devices could be configured. They could be mirrored from the primary site, but not every box you have, not every server is going to be mirrored at a warm site. Now, disaster recovery using a warm site will still take longer than if a hot site were maintained, but basic communications are back in place much more quickly than if a cold site was used. The mission critical servers are going to be ready to go, but most likely you're going to need some time to get your secondary servers back online. And notice that I did mention about keeping data off-site and keeping your backups off-site. It's not a good idea to have your backup data in the same building or in the same room with your devices. Because if something happens to those physical devices, your servers, something probably is going to happen to the tapes. A lot of companies have a service that comes in the afternoon and picks up their tapes and takes them to an off-site location. So in case there is a disaster, they can get those tapes and then restore their servers. So keeping off-site backups is vital. Very, very important. Well, we're almost at the conclusion of this video. And at this point, if you've gone through the plan, you've decided on a backup media, and you've decided on a backup strategy, you've got a backup schedule going on, you've got a chart someone has to sign every day when they're signing off that the backups were done. That's all great, because the one big question that you have to ask yourself is simply this. How would you recover if your server room disappeared tonight? And I'm not asking you that to scare you. It's just something we have to deal with as network admins. We have to say, if a storm came through tonight, if a hurricane came through tonight and knocked the building down, how would we recover? If something, some man-made disaster happened, what would we do? What's our plan? That's what disaster recovery is all about. And earlier we were talking about RAID and drives going down and that kind of thing. That's not a true disaster to me. I mean, a true disaster is something natural, like a hurricane or a tornado that just takes you out. And again, if the entire building that holds your servers disappeared tonight, what would you do? If you have offsite backups, you have a starting point. Because it doesn't matter what the media is that you use, it doesn't matter what the backup schemes that you use, you've got to have a copy of that data kept off-site. That is the real key to disaster recovery. Let's take a few minutes to review this particular section because we've got a lot of comparisons here. We've got power supply options we have to be able to compare, the several different levels of RAID we discussed. We have to be able to compare and discuss the backup methods and the media and, of course, the sites, the disaster recovery site types. And we'll start with a look here at the power supply options. Surge protectors, as we mentioned, they have the lowest fault tolerance because really they don't have any. They're handy to protect against normal voltage surges, but they're not going to protect the home PC against a lightning strike. And when the power blinks, the power blinks. A surge protector doesn't help us there. What does help us is a UPS, an uninterruptible power supply, which has good fault tolerance. And that's a broad way of putting it, but it really depends on the capacity of the device and the number of other devices we have connected to the UPS. And again, we really want to guard against the UPS running out of power and our PCs and especially our servers going down without being properly shut down. So when we hear that fast beeping, we want to get over there and shut that box down. Line conditioner, it's excellent fault tolerance, it's very expensive, and that's really about all you need to know about a line conditioner right now. We talked about RAID. This is a method of bundling multiple physical drives into one logical drive. And I may not have used the word bundling when we talked about RAID earlier, but it's a common networking term I want you to get used to hearing because as you progress through your studies, whether that's Microsoft, Cisco, or any other vendor, you're going to see situations where multiple devices can be bundled logically into one, and that's what we're doing with RAID. So I want you to get used to hearing the word bundle or bundling. RAID 0 has disk striping and no parity, and unfortunately for us, it also has no fault tolerance. One down drive, and that array is down. Any disk striping scheme requires 3 disks at the least. So with RAID 0, 3, and 5, we've got to have at least 3 hard drives. The smaller drive determines the maximum size of the array. We saw that where we had a 100 meg drive and a 3 drive array, and we could only stripe 100 meg on the other 2 hard drives, even though they were much larger. RAID 0 does help, though, even though there's no fault tolerance. It does allow for faster read-writes or faster input-output, however you want to put it, and it does give us higher productivity in that way. RAID 1 is disk mirroring, so only 2 drives are absolutely required for RAID 1. If the primary drive goes down, the mirror drive immediately fills in. It should happen so fast that the users are not even aware of it. Now, when we do replace the primary drive or the one that went down, we're going to have to synchronize that drive when we replace it. And that's actually a pretty simple thing now. Usually with that, whatever software program you're using to manage your RAID devices and your RAID arrays, it's going to have an option for synchronization. So it's very simple, but we need to remember to do it. Otherwise, that mirrored drive is not doing us much good. There is some fault tolerance here with disk mirroring. That's what it's all about. But there's no improvement in performance because you're still writing to one disk all the time. And then the contents of that disk are being copied to another. RAID 3, disk striping with a dedicated parity drive. We mentioned how it uses the ECC using parity bits for error detection but not correction. Parity settings are checked when data is written and then again when it's read, and we talked about if the parity settings have changed, then the data has become corrupt and there may be a problem. The problem with RAID 3, the drawback, is that it requires a dedicated parity drive. We have to have one hard drive that's doing absolutely nothing but taking care of parity. And again, disk striping requires a minimum of 3 drives. Disk striping with distributed parity, it's similar to RAID 3 in operation, but there's no dedicated parity drive. Just as the data is going to be written to all your drives, the parity information is written to all 3 drives as well. So we don't have to waste a drive, if you will, just with parity. High fault tolerance, higher than anything we talked about up to this point with 0 and 3, and it does require a minimum of 3 drives. Discussing RAID 6 and RAID 10 for just a moment, both of these require at least 4 hard drives. So keep that one in mind. We've discussed now 0 and 3 and 5 all require at least 3 hard drives. RAID 1 only requires 2, but RAID 6 and 10 actually require 4. RAID 6 uses something called dual parity, which is actually 2 separate parity schemes or operations going on at the same time. Both RAID 6 and 10 allow recovery from multiple simultaneous disk failures. So if 2 of those 4 drives go out, we can actually keep working. That's pretty amazing. With RAID 10, just a few additional notes. RAID 10 is actually a striped array of RAID 1 segments. Excellent input-output rates, absolutely fantastic. And of course, we got to have a trade-off because this is networking. It's very expensive and high overhead. And those are 2 phrases that for some reason network managers just, they don't want to write the check after they hear that part, right? For our backups, the full backup is just that. All files are backed up and the archive bit is cleared after the file is backed up. We mentioned the archive bit is a notification as to whether the contents of the file have been changed since the last backup. Now, incremental backups, all files created or changed since the last backup are backed up, and the archive bit is cleared. The differential backup, all files created or changed since the last full backup are backed up. The archive bit is not cleared. So if you're running differentials during the week, you could be backing up the same files every night. There's nothing wrong with that. Again, it's really up to you. And when you're deciding whether you want to use incremental or differential, you might want to read some of your software vendor documentation to see what they recommend. Where it comes in, as far as the difference, where that comes in is when we're looking at what tapes we need to do a full restore. If we're running full backups on the weekend, say in incrementals during the day, and we have a problem, some data is lost, and we need to do a full restore, what we're going to need is the last full backup and all incremental backups since that full backup. But if we're running differentials, the last full backup and the last differential backup are all we need. We mentioned a couple of media types. As far as the backup media, I mentioned tapes a lot during these tapings because that's what I've used for the most part. I have saved to CD. That does take longer, of course, as technology advances. It's going to take less and less time, but backup to tape is still a little bit faster. And of course, we could just have an external drive actually attached to the server that we're backing up, and that is direct attached storage. Again, technically, the internal hard drive of a computer is direct attached storage. I don't think that's going to come into play on the exam, but I want you to know that some people feel that way and some people don't. Network attached storage, NAS, is storage device or devices placed directly on the network, and SAN is NAS taken to the next level. It's storage area networking. It's actually an internal network of storage devices on your network. It's like a storage subnet. And this is found on enterprise WANs right now, but again, this is one of the fastest growing areas of our business. So if you want to look for something to specialize in down the road, that's a good area to look at. We talked about the disaster recovery plans and the type of sites that we can have for that. With a hot site, all the servers are mirrored from the primary site, and the office furniture and phones are ready to go. You should be able to walk right in and get to work. That's what a hot site is all about, and of course, that's why it's so expensive. With a cold site, no servers are mirrored. full restores and installs are going to be needed. So you're going to be spending a lot of time just getting set up. So obviously, between hot sites and cold sites, we need a middle ground, and that's why we have the aptly named warm site, because critical servers are going to be mirrored. You're gonna have the bare bones, or I really should say the backbone of your network. Your backbone's going to be ready to go, but some of your other secondary servers, and I know nobody ever thinks their server is secondary, but some of the less mission critical servers are going to need to be rebuilt from a restore. So that wraps up our disaster recovery video. I hope I didn't scare you too much when I was talking about how serious some of this is, or actually all of it, because we've got to be prepared for disasters today, whether man-made or natural. And one more thing that I would add to this, if your company, if your office, if your network does not have an off-site tape storage, or however you're backing up your data, whether it's CDs or tapes, you've got to store those off-site. There's got to be a copy somewhere. And I know that some smaller networks, and occasionally, schools are a little guilty of this. They'll back data up, but all the backup tapes are right there in the same room. If something came through, if a storm came through or something else happened that would actually destroy the server, the tapes would probably be gone too. So the one thing I want to mention to you here as we wrap this up is, if you're not storing your data off-site somewhere, you need to look into doing that. I recommend that very highly. So that's about it, and I will see you on the next video.